Multiplying special cases. What is so special about these two binomials? Well, look at them both and they are squared. They're both put to the power of 2. You might be on the other side of that screen going, well, what's so special about that? Nothing really. There really isn't, except for the fact that I can teach you a quick little trick when something like this pops up. Okay, good mathematicians want to know this trick because it's like a shortcut. It makes it a lot quicker and easier for you to find this simplified form and get to where you need to go much faster than having to do it the long route. So let's talk about what that long route is first off. Some of you might look at this and go, well, Bielik, isn't that n minus 7 times itself? And you would be, ding, 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 correct. That is exactly what that means. Now, some of you might also be going one step further and saying, well, I already watched your videos that you just posted. You showed us how to do the FOIL method or the distributive property or using a table. I can do this. Yeah, you can. But that takes time. All right. When you are given this special case, when something's squared, you as a mathematician should look at it and say, sweet, I can do this one really fast. It's not like the other ones that I was asked to do in the previous chapter. Okay. Now, if you want to go first, outside, inside, last, by all means, go about that route. It will take you time. I'm going to show you a trick right now. Hopefully you take the time to learn it, because once you figure it out and you understand it and you have it memorized, things become much faster and easier for you on these specific problems. Why are these problems specific? Because they're special. All right? They're special. Here we go. N minus 7 squared. Well, when we have a special case, it's typically going to show one term added to another term, and then we're squaring it all together. The rule is when this happens, whenever we take a binomial and square it, you can just take the first term, square it, the second term, first term squared, second term, square that, and then in the middle, you just have to multiply these together and then say times 2. So that would be 2 times A times B. 2 times A times B. That's our rule. I personally, the way I like to tackle these problems is I take care of these first because they seem to be quick and easy for me. Might not be the same case for you, but these just square them real fast, write them out with a space in the middle, and then you can take care of the middle term, which to me the middle term is probably the most tricky of them all, but it's really not. Once you get the hang of it, you'll get used to this. So let's go about it the way I would do this problem. I would say my first term is n. All I need to do with my first term is square it. My second term is negative 7. So I'm going to give myself some space, write down negative 7, and all I'm supposed to do with that second term at the end is square it. And then in the middle, I need to say 2 times both of my terms on the inside. So that's 2 times an n times a negative 7. Now I'm one step away from solving this. N squared stays n squared. 2 times n is 2n, and 2n times negative 7 is negative 14n. 2 times n is 2n. 2n times negative 7 is negative 14n. And then negative 7 squared, got to be careful there. A negative squared is really going to turn out to be a positive, because what this means is negative 7 times negative 7, and that makes a positive 49. Final result, trinomial, written out as you see. Now, could I have gone about that by saying n minus 7 times n minus 7 and using the FOIL method? Absolutely. But I would hands down have to bet that this right here is much quicker than anybody using the FOIL method or the distributive property or the table method. Okay? This is a tool you want to have in your belt. Okay? You want to make sure that you understand this, memorize it, because when this pops up, you should be happy. Okay, when you see, oh, they just want me to square a binomial, piece of cake, those ones are easy because I know my rule. This is a law of math. It doesn't work sometimes. It works every time. All right, this one right here, 2x plus 9 squared. So again, take that first term, write it down, and then square it. Take that second term in the binomial, give yourself space, write it down, and square it. And then in the middle, say 2 times, I like to use my parentheses. They're always important. They help you separate things. And then just put both of those terms into each one of those parentheses. 2x and 9. Okay, good thing that we learned our exponent rules, because 2x squared is going to be a 2 squared x squared, which would be a 4x squared. 2 times 2x is going to give me 4x times 9, which is going to be 36x. It's a positive 36. And then at the end we have a 9 squared, which we all know 9 times 9 equals 81. And we have our final trinomial. Again, could you have gone this route? Hey, Mr. Bielik, if I'm squaring this, doesn't that just mean 2x plus 9 times 2x plus 9? And then you do your first 4x squared, or outside 18x, or inside 18x, and then our last 81. Combine these, I get 4x squared plus 36x plus 81. Could you have gone that route? Absolutely. Notice we have the same exact result. I will tell you right now, once you have this memorized and you've practiced it, you can do this very, very quickly. All right? But by no means am I going to force you to do that. Use whatever method makes more sense to you. If this is tricky for you to memorize, that's okay. You always have this as a backup plan, but promise you, this is going to be a helpful law of math for you to know. Hopefully this makes sense. Study it. Practice it on the assignment that I gave. I gave you guys a few problems to do, and study for your upcoming test.